in Lesson 4.9, you'll be using indirect measurement to solve problems involving similar triangles. One of those indirect measurements is called shadow reckoning. If you go out and measure two shadows at the same time of day, you'll be able to use that information to help you find the height of something that is maybe too tall for you to measure or maybe not very safe for you to measure. Like I wouldn't really want to put a ladder up against the flagpole to see how tall it is. So what you can do instead is you can measure the shadows and then set up a proportion to find the missing side. This says a fire hydrant 2.5 feet high casts a 5-foot shadow. How tall is a street light that casts a 26-foot shadow at the same time? Let H represent the height of the street light. Well, what you have here is two right triangles. And as long as these measurements were taken at the same time of day, those triangles are similar. What you're going to want to do is set up a proportion comparing the corresponding sides. H matches up with 2.5. And since I said H matches up with 2.5, 26 matches up with 5. Now this one has some nice numbers that you might be able to recognize right away that H is going to have to be 13, but it doesn't always work out to be so nice. So I'm going to go ahead and show you how to use the cross products. You get 5H equals 26 times 2.5. 26 times 2.5 is going to be 65. And then divide both sides by 5. And you get H equals 13, or 13 feet is the height of the light post. Now that's one way to set it up. You can set up this problem another way as well. Some people like to go like this and compare the item to its shadow. So H over 26 equals the item compared to its shadow. And if you go and set up this problem to solve, H times 5 is 5H. And then 26 times 2.5 is 65. You'll notice you have the exact same problem. It's just set up a different way. And then 65 divided by 5 is 13. So it doesn't matter how you set it up as long as you're consistent and organized with the way you do it. You may want to pause the video and try the next one on your own. It says at the same time, a 2-meter street sign. So let's say here's our street sign. Sometimes drawing a picture is helpful. A 2-meter street sign casts a 3-meter shadow. A telephone pole casts a 12.3-meter shadow. These, again, are right triangles that are similar to each other. So if you want to know how tall the telephone pole is, I'm going to just call that H. H matches up with its shadow, or H over 12.3 equals the other item, the street sign, matches up with its shadow. Now when you go to solve this, you get 3H equals 2 times 12.3, which is 24.6. Now you're going to want to divide both sides by 3. 24.6 divided by 3, that's going to be 8 2/10, or 8.2. And it was in meters. Another time when using indirect measurement is helpful is if you're trying to find the distance across like a body of water or something that's not easy to measure. What you'll see drawn here is two similar triangles. We have this large one right here, and then we have this smaller one right here. It says in the figure at the right, triangle DBA is similar to triangle ECA. Raymond wants to know the distance across the lake, so we're trying to find this measurement right here. Well, D, this measurement right here, matches up with this measurement in the smaller triangle. So D over 40 equals, now since I started with the big triangle and compared it to the small triangle, I'm going to take the big triangle, which is this whole side here. So it's 320 plus 162, which is 482. 482 matches up with, I'll color code it. This side right here matches up with this on the smaller side. Now to solve the problem, it's 320 times D, or 320D. Equals 40 times 482. 40 times 482 is 19,280. Now to solve this, you would divide both sides by 320. When you divide by 320, you get 60.25. So the distance is 60.25 meters across the lake. You may want to pause the video and try the last one on your own. It says find the length of Kentucky Avenue, or sorry, Kentucky Lane. So Kentucky Lane is this one right here. So this road matches up with this one right here. So if I don't know this distance, that distance is going to match up with 6 in the smaller triangle. Now I need to, since I did big compared to small, I'm going to do big compared to small. The big one is 4 plus 4, which is 8. And the small one is 4. So D times 4 is 4D. And 6 times 8 is 48. Divide both sides by 4. D equals 12. And this is in miles, so 12 miles.